Okay, now part B. Does that make sense for the A though? Okay. So the velocity of Miss E. D. Water. Miss E. D. Water. What's that supposed to? What does that mean? Miss E. D. Water. Miss E. D. Water. I feel like it's supposed to be like a funny name, and I don't get it. Anyway, the velocity after the first half second of fall is represented by an arrow. Is it this one then? Probably, yeah. The size or length of the arrow is representative of the direction of her velocity. For the remaining 3 positions in the diagram, construct an arrow of the approximate length to represent the velocity vector. The length is, okay, so the length is the magnitude, and magnitude is the same as a number. So the longer the arrow, basically, the faster someone's going. So that's like if I was drawing like a, like a box on wheels, and it was like, oh, it's going slowly versus like zoom, it's like going really fast. So that's what they want us to do with this falling person. So
it's a small arrow.
It's a small arrow to start, and then how does their velocity change as they go down?
It gets bigger.
Exactly. So you're just gonna like fill that in, bigger arrows. And continuing, obviously, still going down. Okay, and then kinematic equations.
I searched them up on the internet, and I got one of them. I got distance equals vi plus v1 over 2 plus time, or t. I got that for one.
Yeah, v2, and then it's over 2, yeah. That's not an I, that's an I.
It's like I.
Initial and one. That could make, okay. So you're adding 2 things together and dividing by 2. That's an average, basically. So that's your average speed.
Yeah, but just finding these 2 is kind of complicated for me.
Yeah, so, wait, distance. Okay, so actually really all we should need is the speed equals distance over time equation. Maybe not. Because distance fallen and height. Oh, cool, thanks. Those things are just going to be, you're just going to take the difference. So the height, like obviously if you fall 10 feet out of a height of 19.6, then you have 9.6 feet left. So distance fallen, this height equals, if this is x, this is 19.6 minus x. So,
so then would you subtract 9.8 from 19.6?
Eventually. So let's start with the easy parts of the table to fill in, even without the equation. So if we know that the acceleration due to gravity in this situation is 9.8 meters per second, then after 1 second, what would our velocity be?
9.8?
Yeah, 9.8 meters per second after the first second of falling.
Then would you divide that in half for this one so you get 8, or not 8? Just divide 9.8 in half to get the velocity for 0.5.
I believe so, yes. And you would multiply it by, after 2 seconds, the velocity would be 19.6. I remember us discussing that before. So now the tricky part is getting the distance fallen, which I think is this equation. I just am not sure why we're adding the time. Because we're getting a distance.
Unless you want to try to use the regular.
Yeah, but that's not gonna work because it's based on a constant speed, and since our speed is increasing, it's like
just gonna be staying at like a same rate.
Yeah, it's like if I took, 20 minutes to speed up from 0 to 60 miles an hour, I would not have made it 20 miles because I wasn't going 60 miles an hour the whole time. I was going like real slow for the, you know what I mean, as I slowly sped up. So we do need a different equation. We do need one of these kinematic equations for that part, but that's okay. What was half of did you get half of 9.8?
Oh wait, no, I'm not yet.
So half of 9 is 4.5 and half of 8 is 4. 4.5 plus 0.4 is 4.9. So it should be 4.9, and then this one is going to be like 9.8 plus 4.9. What's our ending height going to be?
The ending height?
Yeah. If the thing is only 19.6 meter, well, I guess we don't know actually. Never mind. We got to figure that out. Okay. So you're going to check my work on a calculator. So looking at this equation that we had before, based on the units, we figured out that it has to be multiplied by time because we have initial velocity and the next velocity. We're taking the average, adding two things together, dividing by 2. Velocity is meters per second. So in order to get
2.45.
perfect, that's 4.9 divided by 2, right?
Yep.
So then you have to multiply that by 0.5.
Okay, times
Mental math.
1.225.
Yeah, mental math for the win. Okay, so we have meters per second. We multiply by seconds in the form of time. And the seconds will cancel out, leaving us with the meters, which would be distance. So that's how you can use units to figure out an equation if you're not sure. So what we did here is to figure out the distance, we took the initial velocity, which would be the first one up there, add it to the next velocity, 4.9, divide by 2, which gives us 2.45, multiply by 0.5, 1.225.
Does that mean the next one, VI, will be 1?
Well, that 1.225 is going to be the distance fallen, right?
I know, but when you plug in for the next one, instead of plugging in 0, you'll plug in 1 next time.
No, the next time you'll plug in, the 0 you plugged in comes from this velocity. So the next velocity under that would be 4.9. So you would do 4.9 plus 9.8 divided by 2. So for this one, it's going to be D equals
And that would be 14.7.
divided by 2, and then divide by 2. So then you're going to use that same equation. So it's going to be 4.9 plus 9.8 divided by 2 times 1 second.
2.35, and then you multiply that times
1.
1.
Yeah. So it just stays as 2.35. And to get that height in the last box, it's just going to be 19.6 minus the distance fallen. Right? So if you are starting at 19.6 meters, you fall 1.225, then you end up there. Though, wait. Hang on. So we are supposed to be speeding up. So I would expect that if we fell 1.2 meters in the first half a second, then we would have to fall more than 1.2 meters in the oh, wait. Okay. So this 2.35 meters, just to be real specific, this 2.35 meters is how much we fell just in the half second from 0.5 to 1. So to get our total distance fallen for over here, it's going to be these two things added together. If we wanted to get the total distance fallen, then we could use that same equation. The distance equals starting initial velocity plus the next velocity divided by 2 times time. But you would do, let's see, distance equals 0 plus 9.8 divided by, wait, okay, so we did something wrong. I did something wrong. 0 plus 9.8 divided by 2 That's the thing that you would multiply by 1 if you wanted the total distance. This one, since we're doing 4.9 to 9.8, we would multiply by 0.5, which would give us 1.15 plus 2.17, which is like not right. What was the 9.8 divided by, just 9.8 divided by 2 is
4.9.
4.9. I think that's why it's using VI, is that you always have to use you always go back to the starting velocity of 0. So we don't do it this way where you plug in the 4.9. It would be like 0 to 4.9, 0 to 9.8, 0 to this number, 0 to 19.6.
So you just always be adding 0 for the VI.
So it's basically whatever that speed is divided by 2 times the total number of seconds is going to give you the total distance fallen.
So 9.8 divided by 2, that is 4.9. And then you add the time, or multiply the time, which would be 1, so it would still be 4.9. Do the same thing for the next one, since it's 14.7. Divide that by 2. Get 7.35, and then multiply that times 1.